Good afternoon, ladies and gentlemen. My name is Hojun Song and my major is automotive engineering. Today, I'll give you a presentation about a reducer that we've made during class. Start off the presentation, I'll tell you the contents of today's presentation. First, I'll start off with an introduction. In the introduction, there will be our project goal and the plan. After that, I'll show you the members of the team and their roles. Next will be the progress of the project, and last will be my reflection. The name of the class that we did this project is Machine Element Design. Our project was to make a reducer using helical gears. So the given options were to use a helical gear, and the total reduction ratio should be 9:1. And finally, we had to use a specific bearing. Our overall plan was this. First, we had to choose which car's reducer to design, and after that, we had to design each gear's shafts, housing, and the bearing considering the car's specs. After that, we had to print it out by using a 3D printer. We had four members participating in this project. First, it's me at the top, and I was the project manager. What I did was I designed detailedly, and I was supposed to do the 3D modeling. Mr. Lee was to write up the documents and help me with the 3D modeling, and Mr. Ha helped us with the detailed designs and also participated in the modeling. And finally, Mr. Chai helped us with the modeling, and he did the presentation. When we were choosing the car, we had four different options. When deciding a car, we thought of four different considerations. The considerations were rarity, vehicle information, year made, and lastly, the full charge range. Taking this into considerations, we chose Tesla Model Y. After that, we had to design a gear. Our professor gave us a specific reduction rate as 9:1, so we decided the number of teeth in the gear to 22, 65, 22, and 67, so that the first stage of reduction rate will be 2.95 and the second stage of reduction rate will be 3.04. So if you multiply those two numbers, it's going to be a total of 9. Next, when the number of tooth are decided, we ran an ANSYS program using this. We can make a gear by a specific material and we can find out the precise mass and the volume of each four gears. After that, we made the gear by using 3D modeling tool called CATIA. The next step is to make the gear shaft. To make the shaft, we had to consider the mass and the volume. This diagram shows the horizontal load and the moment that is applied to the shaft. So considering the maximum and the minimum bending moments and the process of calculating this graph shows you the specific diameter that we came up with. And below that is the 3D modeling that we've made according to the numbers. These two pictures shows the connections between the gears and the shaft. As you can see, the front two gears are connected. So if you rotate the first gear, the second gear will also rotate. And the second gear and the third gear is connected by the shaft. So it's going to pass on the force and the final reduction ratio will be a total of 9. To protect the gears and the shaft, we made the housing. When designing the housing, we had to give some tolerance so it works smoothly. And we made up so that it opens easily. This is the final result of our project. Through the project, our teammate made up every Tuesdays and Wednesdays. These are some photos of us doing detailed designs and making the 3D modeling. Looking back the project, we had some difficulties, but we've learned a lot from the project. To tell you briefly about it, it was difficult for us to design an actual reducer because there are too many things to consider. And it was also a long-term project, so it was hard for me to work out a project as a team. But through this project, I've learned how to make a reducer, and I also learned how to manage a project efficiently as a project manager. Thank you for your precious time.